um, the UML diagrams. I will start talking about use case diagrams, follow with sequence diagrams and state diagrams. As I collect information about this topics, I want to discuss and show the implementation of such. The use case diagrams are very simple when it comes to explaining the basic terms of how the users use the system or will interact with it. These diagrams are part of the design logic, and they show what elements are involved. As part of the this use case, it shows what parts of the system the different user will actually use. This is important because not all users will have the same interaction with the system, and it is a good guide for the developers to know what the system will be doing. The use case diagrams use this notation. You always start creating the use case or the parts of the system that would be involved on the program, basically. And let me jump into the diagram to explain it a little bit better. So here in this diagram, these ovals are the use case. And I'm thinking about doing an application where represents or simulates a application for a shopping cart or a grocery store shopping cart. And on this application, the user will be able to open the let's say Android application and create a new list or use an existing one if he's done it previously. He will be able to add and remove items from the list or the shopping cart in this case. So each of these ovals are the cases or the time when he uses a specific class, I guess you can say, on the of the application. And you can see that all the ovals are inside this rectangle. That means that this is the system itself. That's why they're all cases are contained within the system. And the little guys here, they call actors, or in this case you can say the user. They're here to show how the user or the actor in this case is outside the system, because that's what happened. You know, the user is not part of the system; he interacts with it. So you can have a regular, user, an administrator who would have privileges to remove and add data from databases, and the actual database which can be part of the system, or it can be as well external to it. And in this case, it would be external because it would be from a different source pulling this database. Although the administrator will be able to use that. So that's what a use case looks like, and this is the notation that they use. Some of this the lines would denotate the relation among the cases. Some of them are just two-way communication between the cases, or they implement the functions of one of the cases. In this case, when you denote extend or includes, it represents a communication that is just one way, and these ones denotate that they're both way communication. So now let's jump into sequence diagrams. Sequence diagrams, there are a bit more detail and description of what the system will do. They are part of the logical view of the system as well. What makes them different from other diagrams is that they follow a timeline. In this timeline, you have to describe each step and how data, input, or messages travel through the system. They show the way things will be executed and the expected result of that interaction with the system. Again, let me jump into the diagram to explain a little bit better. The notation, I have the notation for these diagrams as well here. You want to start with the actor or the user in this case, and it's represented by the stickman right here, and the other objects associated or involved in this process are notated in these rectangles. The line here, as you can see, this dotted line represents the lifeline of the object or the user. So, and it also represented with this solid line that represents the time that the application is working. The arrows here represent the messages or the triggers, you can say, on the application, on the script, that direct the communication between the objects on the system. The dotted line represents a return message, what happened after the previous or the initial message has been processed and returns the value, data, or whatever that is doing. You can also have self messages, which can be helpful to determine actions based on logic the system will be testing. If a command results true, then it would do something. If not, it would return itself back to the application or the object in this case. Like I said, it's a little bit more in detail than the use case. As you can see here, this is very simplistic way of showing what the system will do. And here it's a little bit more step by step. In this case, I have the shopper, which is the user of the application. He will start by sending a signal to create a new list or request an existing list, and then depending on the message that he's sending to the system will then execute a different part of the code. If he creates a new list or selects an existing one, then he would want to add or remove items to the list, and that would happen here. The same thing. The objects that is in charge of that would be executing commands that would require another object, in this case the database, to add or remove items. And it would trigger down until you have completed your task, and the system has done as well, and then you'll be able to finalize or end the use of the application. That's where you will get the messages back into your interface or user interface. So that's what the sequence diagrams are. Now let's jump into state diagrams. This is another part of the UML language that it's essential on the developing software. All three diagrams are helpful for developers to get an idea of what the system will actually do. And here as well, the notation is different, and the actual steps and the diagrams change a little bit. State diagrams are part of the logical view as well. Their purpose is to show, as the word indicates, the state of the system at different steps of the process or the application. What this means is that whenever you have a program running, there are moments in which the script or the code has to wait or transition from one state to another in order to continue with the task. It has to confirm that the task was executed, accepted, or it was true. State diagrams are different from the use case and sequence diagrams in various ways. One of them is the different notation. The state diagram starts with this solid dot that is called initial state or initial pseudo code, something like that. Pseudo state, I'm sorry. From here, the application will start executing, and then it would wait until you indicate whether you want to create a new list or search for an existing one. As you can see here, the state from this list would change to existing list or a new list, and between this is the transition, which is represented here on the lines. Also, the state diagrams would show how it moves from one state to another. Sometimes they can be correlated, or in this case, using some of the same states as you move on the system. There's also another part that I didn't add on my diagram, but that is the it's called composite states, where it can be two things happen at the same time. So that's what a composite state means, when you have two tasks or situations happening at the same time. So moving on this, you have the state where the shopping cart has add items to the list and is now idle, and waiting for you to save it or delete it. So the system then can start the finalization and end. The end of the program or the system is represented with a solid dot and circle with this line. So here's what my findings and what I've learned about UML diagrams. Again, we talked about use case, sequence diagrams, and state diagrams. So there he is.